May the 19th, 2025. Guys, it's been a hot day today. Sunny here in central Mississippi. The rains have stayed kind of north of us that we're crossing the state. Right now it's 87. The real feel is 100 degrees. Humidity is 74 degrees. Been a little warm in the shades, not too bad, but if you get to moving around too much, that humidity will catch up with you. At 100 on the real field temperature, guys, that will drain you pretty quick, and you got to be careful. And this has a lot to do with that, and it's going to be continuing. This this coronal hole that you're seeing here, if it looks familiar, that is because it is. This is the third rotation. You know, about every 27, 28 days, we get a rotation of a sunspot or a coronal hole or whatever's still there. It doesn't dissipate on the back side. And this one is, right now we're in a minor G1 class geomagnetic storm, and they're possible for the next 3 days. Yesterday's forecast basically showed that today and tomorrow would be not a geomagnetic storm, what they call a G0. But we're in a G1 now, and that could pick up. And I'm going to look at the solar wind speed and things like that. But this is that same giant, some call it, they say, black hole sun. And it's actually showing up blue here. But you've got three cameras that give us this particular picture, and each one has a different filter on it from the Solar Dynamics Observatory, and they overlay each filter to get this. And again, the blue areas are openings in the magnetic canopy of the sun. And all of this, you see the loops and everything. So when you do not have these big magnetic loops, and what they're doing as they're looping, you can see around the edge here, is their energy is being released from the sun and then fed back into it via those loops. Well, when those loops aren't present and you have this open canopy, then it's fired straight at our planet when it's Earth facing like this. They're saying this gaseous material is flowing from a hole in the sun's atmosphere, which stretches across most of the sun's southern hemisphere. The million-kilometer-wide structure is shown in the extreme ultraviolet image from NASA's SDO. This is a coronal hole, a region in the sun's atmosphere where magnetic fields have opened up, allowing solar wind to escape. Coronal holes look dark because hot glowing gas normally contained there is missing. In this case, it's en route to the Earth. Now let's take a look at the real-time solar wind chart. If you remember yesterday, we were impacted with that large filament that left the top half of the sun, the northern hemisphere. And I complained about them not putting up a CME tracker model for that thing because I knew we were going to get a glancing blow. It's on the Earth-facing side. It's kind of simple. But what happened was the density picked up in our solar wind was up here above 650, up in this area, right in there, getting to about 675. And so as that effect from that filament release has passed by the Earth, it started to die down. See this and kind of level out right in here. Then suddenly we were hit right there. It goes from trying to get back. That's not normal, but it's better than what it was. 320 is normal, and you see that's not even showing on the chart here because it's elevated. And then it starts getting very agitated again. That is because of the coronal opening that I just showed you, and my huskies are agreeing with us. Density's up. The solar wind is fluctuating, but right now it's in a rise, and we're going to be, again, a G1 magnetic storm, at least a G1 for the next 2 days. Temperatures feeling the same thing as this disturbance. And one thing about it, the shields are closed right now. That's a real good thing. They were open here. You can see the gap. And right now they're closed. Will that reopen? We don't know yet. But we do know that the combination of this constant solar wind can be very irritating, and right now, guys, we're dealing with coming into hurricane season, and all of this radiation pouring down onto the surface of the Earth and the surface of 3/4 of the Earth's surface, the oceans. Now, something else we may have to pay attention to is right here. So we had a pretty good sunspot this morning. I think this was an M3 or something like that. Anyway, where that came from was from the left side of the sun. A new sunspot is emerging and is going to be rotating behind this large coronal opening that we're dealing with now. Now let's take a look at the SDO, the satellite. We were just looking at the combination of 3 different cameras on. There's 12 different ones total. And you'll notice in this area, as the day goes on, that you'll see that flare. If it had been Earth-facing, it would have been an X flare. You can tell by the signature, but if they're not directly Earth-facing, the satellite, there it was. The satellite's picking up the energy. They only get a side blast, but it gets to the Earth in 8.2 seconds. But that is exactly what we're dealing with, a coronal hole. And as it tries to move away from directly Earth-facing, we've got another group of sunspots that are very active. You see that flash? That's a telltale sign that it was an X flare, just not directly facing the probes and the sensors on the satellites in between Earth and the sun that gives us this early warning system. And at any time the sun starts picking up in activity, I like to look at Cern and I like to look at the magnetosphere. Right now, this is live as we're talking, and you've got the blue and red beam combined here, and it was very quick startup. See that? When they get there, the black line represents the power of the combined blue and red line. Each one is running 6799, almost 6800 gigaelectron volts. The last few years, they were peaking at 6,500 per beam, making it 1,300 tera-electron volts. Guys, they're approaching 14 TeV now, which would be 14,000 giga-electron volts. And beam 1 is blue. B2 is red, beam 2. You can see the power coming through here. Atlas is represented in blue, Alice, CMS, and the Large Hadron Collider B, or LHCb. And they were running pretty strong. Check that out. Notice also, it says stable beams, all IPs are on target, XRPs are in. Now the setup beam is showing a false reading now. That may be because of the declining power of the collisions, but let's take a look at the collisions themselves. Again, we're going to look at it together live. And this is what I've been talking about all of this year. And look at this. They're colliding them pretty perfectly. Now, they'll have to adjust beam 2. You saw beam 1 just move out of the windage and elevation max. But look at how close they've been running. Beam 2 in the orange and tan, and light blue and dark blue in beam 1. But look at that. You saw it as we came over here move. Now they're going to try to get it back over there. That's when they get their God particles, or whatever you want to see it, the energy and their luminosity, okay, is when they get this thing down. And it goes back to talking about this for a few months, is that they've lined some of their plates with a new technology that decreases the heat and the scattering, or what they call a cloud of disinformation. In other words, when these two beams collide, they scatter. And some of that scattering actually escapes those tunnels they're in down there, 17 miles long and very deep underground. But this new plate will stop some of that, and they call it like a fog or a cloud, when you get so much of that distortion from the beam going on that you can't really look at the details. So that helps the ability to look at it, and it helps keep the cryogenics cool. And I'm amazed every time after all these years of watching Cern this year to look at the cryogenic page and see a full green line. Most of you know CMNITR1 is one section of this large collision tunnel. Each one is a different one. If any of these go red, it basically shuts down the control of the entire system. And it will, this red line that you're seeing, I'm just repeating this, guys, for some people that maybe have not seen this before, is a combination of the colors of each of all of these sections. And so if you see like a blue line or green line bouncing up, then that section is when above 2 degrees Kelvin, which is the temperature of outer space. There's a lot of things tied into that temperature, by the way. Anyway, running extremely smooth. That new plating that they talked about, I talked about it in the first video this year of Cern. I don't know exactly what the coating is they use, but it really helped. It helps them, but it keeps the temperature down. And guys, I think, and it's not that I think, because I've saw it for too many years, when they start reaching these powers and they're starting to hide our magnetosphere models, it would collapse that model all the way down to the satellite band. Do you understand what I'm saying? Down to where direct TV floats around at 22,400 miles or 22,000 miles, somewhere right in there, much higher than your space shuttle and things like that. But down into that area, the shields were collapsing, guys, when they would crank up. Guys, this is basically the luminosity page, and it's called Proton Physics Stable Beams, but you notice luminosity and pile up. I think this is their magic that they want to achieve. They achieved it last November, the November before that, and shut down Cern. But they want it higher now. And you can see luminosity here. This is Atlas. That's the giant machine. Atlas, LHCb, smaller version of Atlas, and then the CMS. And you can see they all reached very high luminosity at one point today. And I think that's, again, going back to them discovering the God particle. And they talk, different people have different theories. Talking about that's when the luminosity peaking is when the stargates open. Things like that. And some people will say that they're doing it to protect the shields because the sun, problems with the sun, things like that. And but when you see them collapse because of the energy in CERN, again, repeating that it's 100,000 times more powerful, let me say this. The magnetic field that CERN creates, any type of moving motor or anything electrical will create a magnetic field around it. Even the motor in your air conditioner or refrigerator anyway, the magnetic field is created, but CERN's is 100,000 times more powerful than Earth's. So you can see how easily it could affect it. So the theory, or one of the theories, that it's here to protect us from possibly weakening shields doesn't quite float when you see it collapse them, right? But you also know that there's a big statue that was dedicated by India. They've got a lot of scientists from India there at CERN, of Shiva. Shiva has two meanings. It's the dancing god. It can dance in creation and it can dance into destruction. So you understand why I'm concerned about CERN just a little bit. But again, if it was not for the fact, and they've hid that particular model, that we saw it too many times, our shields collapse. What happens then? More radiation pours into the planet. The heat goes up, hurricanes intensify, all this fog and dizziness intensifies, the body pains and aches intensify when the shields are weaker. Guys, and as a side note, the scientists have went back and looked at, and we've talked about this before, you can tell when lava hardens, the magnetics in it. In other words, was the magnetic poles of the Earth flipped? And this goes back a long time, so we don't have any modern information about it. But they found out that when major catastrophes happen on the planet, our shields are weak. And that makes sense because you get more solar radiation in, more forest fires, more hurricanes. They also discovered that there was a change in those points in the Y chromosome and in the DNA. So you had events in time, in history, with weak shields contributing to major changes of humanity and of the geophysical aspects of our planet. And while we're talking about that, let's look at this particular model, which is not the same as the old ones. It's different, it's better in some ways, but it's worse in other ways. But let's play it through, and you're going to see, as we do that it starts to come down some in solar wind speed and kilometers per second as the intensity of that large filament that released in the northern hemisphere touched the Earth and created the G2 magnetic storm. You're going to see that ease off, and then you're going to see the solar wind from that opening or coronal hole start affecting the planet. Watch this. The Earth is in the center, guys. The red and white, or red and black, indicate that the white side is the sun-facing side, okay? That's what we're looking at here, a side view and a top view. There is the first burst from the coronal openings. You see it get very red everywhere and bending in. Now, the old model would show this opening right here in the what's called the magnetosphere, not the magnetopause, but the magnetosphere here. But it showed this line much clearer. If you pay attention to it, you can see how it will collapse. But they took that particular model that indicated this collapse of this section right here back into our planet. They removed that. I don't know, again, if it's funding or they know something's coming, and there's something coming on this planet, guys, and it's intensifying, and it's been doing it since 2020. And we'll talk about that pretty soon. But the sun is heating up. We're starting, and this is the chart just above the solar wind speed, guys, and you'll see the same things happen. It starts to taper off somewhat as the effects of the filament release, and then intensify because of the coronal opening. And you'll notice the openings here that I've talked about before. They're not very intense now, but that's where shields have what's called cusp, and radiation pours in. Let's play this forward. Again, today, notice the very dark blue here. Keep an eye on it. Starting to smooth out, pull. Look at that, man. That's the first wave. Here's the second wave of that coronal hold. Now, that's going to keep up for a few days. So if you're feeling the intensity of this, you're seeing why. It's going to be in waves, and that's the way that when you have solar wind, guys, it does not travel like like photons at 8.2 minutes to reach our planet. The protons will take a couple of days. We're just starting to see the initial impact of that. In other words, there's a tremendous difference in the speed of a density cloud than it is the speed of light. And let's take a look at the pressure. Check this out. Again, same situation. Here is your top view. Here's your side view. That's why it shows this tilt. We are tilted down in the summertime looking at the sun. Also, we're closer to the southern hemisphere. There it comes in. Watch the expansion. It's like a water balloon. You've got what's called a plasma shield, part of the, or plasmasphere, part of the entire shield system. And it senses an incoming solar wind jump in speed or a solar flare, whatever it is. And it will extend that plasmasphere out. Then when something hits it, it squeezes it in, and then it expands back out very quickly. So you've got two things happening on our planet. That compression, or the pressure you notice at the top, will put pressure all the way to the surface and on our tectonic earthquake plates. The same effect on our earthquakes can happen when you see this release of pressure. In other words, you're pressing in on the water balloon, the surface contracts, you release it, it expands. Both times, though, it is changing and moving. But again, this is a very interesting technology. I wish we had our old one up, but you can see when it starts to affect it, then that it collects enough protons in this plasma to regenerate the plasmasphere and push it back out. It's amazing. Guys, we're watching this. You watch it. There's a lot of information coming out, and you're going to get a lot of it coming very quickly. The Earth is going through some changes, and we're in the end of a cycle that may have very important meanings. So, again, it's time to get everything right, guys. It's a heads up. Be safe.